Hey, it's Horner, and this question is we have a ball that is thrown leftward over here from the edge of a roof, and it's at a height h above the ground. So the ball hits the ground about 1.2 seconds later at a distance of 26 meters from the building at an angle of 62 degrees. So we know that this angle is 62. We know that this distance is 26. And we know that our total time here is 1.2 seconds. So we need to first find the horizontal velocity. And to find that horizontal velocity, we could just use the second kinematics equation. But because this is in the x direction, we don't have any acceleration. We know that the height here, the distance left to right, we are going from right to left, so let's make that negative. Now negative 26 meters, and that's equal to our original speed in the x times our time of 1.2 seconds. Now we can figure out what that speed is. So here the speed is just negative 26 divided by 1.2, and we end up with negative 21.67 meters per second. So throughout the flight, we know that that is the speed. So because this angle is 62 degrees, to find that vertical velocity, because we're dealing with velocities and not positions, we can say that the tangent of the angle should be equal to whatever the absolute value of the final speed in the y is, divided by the absolute value of the original speed in the y. And now we can just say that that final speed in the y is equal to the speed in the x, which is 21.67. Remember, these are absolute values, so we don't need the negative, times the tangent of 62, and we end up with a number somewhere around negative 40.75 meters per second. I did do the absolute value, but then because I know this is going in the down direction and we're saying down is negative, went ahead and put that negative back in if you need to have the true velocity. To find the initial vertical velocity, we're going to use the first kinematics equation to say that our final speed in the y is equal to our original velocity in the y plus the acceleration due to gravity times time. And here we're going to do negative 40.75 meters per second is equal to that original minus 9.8 times 1.2 seconds. And if you do your math, we should end up with an original speed in the y direction of negative 28.99 meters per second. Now that we have that, we can actually do part A of the problem. They want to know what is the height? What is the height of the building? So for that one, we're going to use our second kinematics equation, delta y, is equal to that original speed in the y times time plus 1/2 of gravity times time squared. We know that gravity has to be negative, and so does our original speed in the y, and so does our height. So because they're all negative, let's just leave it positive, and we're going to say that that height is equal to 28.99 times 1.2 plus 1/2 of 9.8 times 1.2 squared. So if we go through and do our math here, we're going to get h is equal to 34.79, and then we're going to add to that 7.056, and we end up with a height of about 41.8 meters. They want to know what is for letter B here. So this was letter A. For letter B, they want us to find the velocity at which the ball is thrown. So we do know the VO and the VX and VOX and VOY. And because we know the speeds in both the X and the Y direction, what we'll do is just use the Pythagorean theorem to find the original speed. So that's equal to the square root of negative 21.67 squared plus, and then we have negative 28.99 squared. So now we are set there. if we go through and do that math, we'll find out that that speed is about 36.2 meters per second. To find the angle, here we can find that angle by doing the inverse tangent. So here we're going to say that the inverse tangent of our y speed, so this is to find the angle of our y speed, which is 28.99, divided by 21.67, which was our x speed, and that should be equal to 53.2, and that would be clockwise from the negative x direction. So if we think about this, that would be all the way around, and then it would be this angle right here. So we'll just point that in that direction. If you want to know that angle from the positive x direction, we just take and add 180 to that, and so that would be 2. We're going to have a 3 here, and then we'll have a 3 here, and this would be 233.2 from, and that would be the positive x direction if you needed to do that. And then finally, they want to know, is that angle above or below the horizontal? And obviously from what we just did, we know that the speed in the y is equal to negative 28.99 meters per second. So the angle would be below the horizontal. And that is the end of that question. So let's go ahead and take a look at the next question. So for this one, they want to know how high this plane is when a decoy is released. We know that the airplane has a speed initially of 281 kilometers per hour. And the angle here is 30 degrees, so it's below the horizontal. And then it releases this decoy, which then falls in free fall. It does have an initial velocity that we'll have to find. And they tell us that the horizontal distance here between the two is 700 meters. So probably the first thing that we need to do on this one is just find out what is this original speed, but in meters per second. So that's typically what we like to use. So here our original speed we know is 281 kilometers, and we're going to do that per hour. We know that there are 1,000 meters in 1 kilometer, and we also know that in 1 hour there are 3,600 seconds. So at this point we can solve and find out that that original speed is 78.06 meters per second. To find the components, we're going to do the original speed in the x should be equal to 78.06 times the cosine of 30 degrees, and that gives us 67.6 meters per second. And then the original speed in the y will be the same thing, but this time we're going to do sine of 30 degrees, and that gives us negative 39.03 meters per second. So remember, downward, and so we want to make the speed here negative times the sine of 30, and that gives us this, because that component is going in the down direction. So now that we've done that, let's do the next thing, and that is finding how long that decoy is in the air. So to find how long that decoy is in the air, we're going to just say we know delta x is equal to the original speed in the x times the time that it travels. And because there's no acceleration, we don't need the rest of the equation. We already know that the delta x here is 700 meters, and we know that our original speed in the x direction is 67.6 meters per second times time. And so if you divide the two, we find out that it is in the air for approximately 10.36 seconds. Now that we have that, we can figure out how high the plane was when the decoy was released. So this is letter B. Now we're going to go back and do letter A. we know that the height of that projectile should be equal to the original speed in the y times time plus 1/2 of the acceleration in the y times time squared. So here we're going to say delta y is equal to, we said the original speed in the y is negative 39.03. We know that the time to fall is the same as the time to go left and right. That's 10.36. Now we have to subtract from that 1/2 of gravity, which is 9.8, and then multiply that times the time again, 10.36. But do remember that is squared. If you solve that, we should get a delta y equal to negative 930.1 meters. And at that point, we know that that is the height if you measure from the top down. If you measure from the bottom up, it's just positive 930.1 meters. And that is the end of that problem.